All right, let's get into it. Today, we are cracking open the case on personal computers. We're going to translate all that complicated tech jargon into simple stuff you can actually use. Let's demystify the PC and get you ready to build the perfect machine for you.
So you're thinking about building a new PC, huh? That's awesome. But it can also feel like you're just staring at this wall of acronyms, CPU, GPU, RAM, SSD. What does any of it even mean? If you're feeling a little lost in all the choices, don't worry. You're in the right place. We're about to make all of this make sense. Here's our game plan. We're going to start with your quest for the perfect computer. Then we'll meet the core components one by one. After that, we'll get into the all-important motherboard, the thing that holds it all together. Then we'll talk performance, speed, and those pesky bottlenecks. And finally, we'll put it all together to build a balanced system.
Okay, first up, let's meet the core components. You can think of these as the essential team, the all-star players working inside your machine.
The captain of that team is the CPU, the central processing unit. This is, for all intents and purposes, the brain of your computer. It's a lightning-fast processor that's running your programs and executing commands. Literally every single time you click your mouse, the CPU is the one doing the work. Next up is RAM, or random access memory. Now, if the CPU is the brain, think of RAM as the computer's short-term memory. It's like your desk, a super fast but temporary workspace for whatever you're working on right now. And that word, temporary, is key. RAM is volatile, which is a fancy way of saying when you turn the power off, the desk gets completely cleared. So if RAM is temporary, where does everything go so you don't lose it? Well, that's the job of storage. This is the computer's long-term memory. It's the filing cabinet where you keep your operating system, all your files, your games, everything. And it stays there even when the power's off. It mostly comes in two flavors: the older mechanical hard disk drives, or HDDs, and the newer, way faster solid-state drives, or SSDs. So let's just put it all together real quick. RAM is your desk. It's super fast, ready for whatever you're working on, but it's got limited space and gets wiped clean every day. Storage is your filing cabinet. It's a little slower to pull things out of, but it holds everything permanently and has way more room. You absolutely need both to get anything done. And now we get to the specialist on the team, the GPU, or graphics processing unit. I love this analogy from our source material. It calls it an idiot savant. See, unlike the CPU, which is a jack of all trades, the GPU is an absolute master of doing thousands or even millions of simple, repetitive tasks all at the same time. This massive parallel power is exactly what you need for things like gaming, 3D modeling, and all the AI stuff happening today. Okay, so we've met the whole team, but what actually connects them all? How do they talk to each other? Well, that brings us to the all-important motherboard. I'm not kidding when I say the motherboard is your first and most critical choice. Why? Because it connects everything. Think of it like a city's road system. It has these data pathways called buses, and not all roads are built the same. You've got these massive superhighways like a fast PCI slot for your graphics card, and then you have smaller, local roads like the slower SATA ports for some of your drives. The motherboard you pick literally defines the whole map, and it determines which CPU, which RAM, and which storage you can even plug into it. All right, we know the parts now, but let's talk about how they actually perform together. This brings us to the fun stuff: performance, speed, and bottlenecks. It's time to learn the language of fast. The one concept you absolutely have to grasp here is the bottleneck. And honestly, the best way to think about it is a traffic jam. Imagine you're on a brand new 10-lane superhighway where the speed limit is 100 miles per hour. But up ahead, all 10 of those lanes merge into one because of construction. It doesn't matter how fast the rest of the highway is, does it? Your entire trip is now defined by that one slow spot. So here's exactly what that traffic jam looks like inside a PC. Your brand new, super fast CPU asks for some data. But that data is stored on a slow, old-school spinning hard drive. So what happens? The entire system just waits. That powerful CPU is just sitting there, twiddling its thumbs, waiting for that slow drive to find the file. That's a bottleneck, and that's why your brand new computer can sometimes feel frustratingly slow. Now, to really understand performance, you have to speak the language of data just a little bit. You're going to see these prefixes everywhere: kilo, mega, giga, and tera. From a tiny little text document measured in kilobytes to a massive storage drive measured in terabytes, These are the fundamental building blocks of pretty much every spec sheet you'll ever read. Okay, so here's a fun little puzzle for you. This is something that trips up almost everyone who buys a new hard drive. Why is it that when you buy a brand new 1 terabyte drive and you plug it into your computer, it's not actually 1 terabyte? What is going on there? Well, the secret is a classic case of marketing versus reality. See, drive manufacturers sell storage using the base 10 system. You know, the one we all use every day, where 1 kilobyte is a nice round 1,000 bytes. But computers, they work in base 2, where 1 kilobyte is actually 1,024 bytes. Now, that little difference of 24 bytes doesn't sound like much, but it adds up fast. And here's the result of all that math. A manufacturer's 1 terabyte drive shows up on your computer as only about 931 gigabytes. And this isn't just some fun fact, this is super important. It means if you buy a 1 terabyte backup drive to back up a 1 terabyte folder on your computer, it's not going to be big enough.
Okay, let's put all this knowledge to use. For our final section, we are going to focus on building a balanced system by making smart choices for your perfect PC. The absolute #1 goal here is a balanced system. You want all the parts to be able to work together in harmony. Remember our traffic jam? A crazy powerful CPU is completely, totally wasted if it's just sitting around all day waiting for a slow hard drive to catch up.
So here it is, your blueprint for success. Number 1, start with the motherboard. It dictates everything else you can choose. Number 2, get enough RAM. If you don't have enough, your PC starts thrashing. That's when it uses your super slow storage as emergency memory and your computer slows to an absolute crawl. 3, prioritize fast storage. Using an SSD for your operating system is probably the single biggest bottleneck killer you can invest in. 4, match your GPU to your needs and make sure your power supply unit, the PSU, can actually handle it. And finally, if you're building a server or have really important data, look into RAID. It uses multiple drives to protect you if one of them fails.
So there you have it. You know the pieces, you speak the language, and you have a plan to avoid all the common mistakes. The mystery is gone. So really, the only question left is, what will you create?